Today we're going to start Chapter 14, and Chapter 14 continues the study of trigonometry. And what we're going to learn today is something called a law of cosines. Well, a law of cosines is just a formula that we're going to be given to us. And that formula is going to be used to find missing sides of a triangle or a missing angle. So I'm just going to say it's a formula to find the missing parts of a triangle. So what we have with the law of cosines is a formula that we can find the length of one side of a triangle, and that length of one side of the triangle will be expressed in terms of the other two sides and the measure of the included angle. So in other words, if you remember from geometry class, side, angle, side, if we know one side, the included angle, and another side of a triangle, then we can find the third side of the triangle using this formula that they call the law of cosines. And the law of cosines, I'll just draw, this triangle is drawn and is called ABC. And remember, the angles are with uppercase letters. The sides are used, you use lowercase letters, and across from big A is little a, across from big B is little b, and across from big C is little c, or lowercase c. And that's what you have to use, or else these formulas won't work. So there are three different formulas over here that says if you're trying to find side A, you must be given the length of side B and side C, and you must be given the angle measure of angle A, and all you have to do is plug in the numbers that you're given into this formula, and that will be A squared, and then if you take the square root of this, you'll get how long side A is. On the other hand, maybe they're going to ask you to find side B. And if they ask you to find side B, then you're going to know how long sides A and C are, and you're going to know the measure of angle B, and you plug it into this formula. Or maybe they're going to ask you side C. If they ask you how long side C is, you will know how long sides A and B are and the measure of angle C. Well, lucky for us, we don't have to memorize this law of cosines, because if you take a look at your reference sheet, there's something up here called the law of cosines. So you'll be given this reference sheet no matter what test or quiz or anything that you're given, and here is the law of cosines, but it's only this first version that they give you. So what you have to do is figure out what side they're asking for, and you're going to replace this letter right here with whatever side they're asking for, and then put the other two sides of the triangle here and here, and then the angle across from the side that you're asked for down here. And we'll go through some examples so you'll know what it means to use the law of cosines. So down here it says this first formula is given to you on the reference sheet, just like I showed you, so you don't have to memorize it, but you need to know how and when to apply it. But really, you're going to memorize probably this formula. I usually show this as a squared equals b squared plus c squared, because everybody knows that is the Pythagorean theorem. But this Pythagorean theorem, the first part of this law of cosines, is only used with a right triangle, because this would be the hypotenuse. And there's no hypotenuse if you just have a regular, any kind of triangle. The law of cosines works with any triangle. It doesn't have to be a right triangle. There are a couple steps here to use LC is the law of cosines. So if you're not sure what that LC is, you can just put LC underneath here. That's the law of cosines. So if you want to apply the law of cosines, if you want to use it to find a missing side, all three sides of a triangle and an angle must be represented, and my big thing here is to draw the triangle. So you're going to draw the triangle and you're going to label it. with all three angles and all three sides with whatever letters they give you. It doesn't have to be A, B, and C. It could be R, S, T, and down here we've got a PQR triangle. So whatever the letters are, you're going to draw the triangle first. And then, to use the law of cosines, you're going to start with the length of the side opposite the angle you're given. So you're going to know the measure of one of the angles, and you start with that length of the opposite. And that's the one you're trying to find. And then here's just a kind of a summary of what the law of cosine says down here. And then you're going to substitute into whatever the formula is that you've written down, and then you're going to solve for that missing side. So what we have here is, in example 1, is we have a triangle called PQR. So the first thing we're going to do is we're going to draw that triangle PQR. And it doesn't matter where we put the P, the Q, the R. So I usually just start down here, P, Q, R. It doesn't really matter. This could have been the P, Q, R. But what we have is, we haven't labeled the sides. So if this is big R down here, then this is little r. If this is big P up here, then this is little p across from it. And here's big Q over here, so little q will be over here. So make sure those sides are marked correctly. They're telling us that the measure of angle R is 42 degrees, so we'll put 42 degrees in that corner. They're telling us that little p is 63. So that length is 63 centimeters or inches or miles or whatever. They don't give us the units. It's just 63. And little q is 107. So we'll put a 107 up here. And now they're asking us to find side PQ. Well, here's side PQ right here. Well, PQ, side PQ is really little letter r. So we're asked to find little r. So if we're asked to find little r, what we do is we start the law of cosines here. Instead of an a squared, we're going to put an r squared because that's what we're finding. So r squared is how we start out this law of cosines. So we have r squared is equal to, and now we put the other two sides into these positions. So the other two sides are p and q. So we have p squared plus q squared minus, don't forget the 2 in the front of that, times p times q times the cosine of the angle that they're giving us is angle r. Now make sure that these two letters on the outside match. If you start out with a little r, you've got to make sure that you've got the big R at the end. So make sure those letters match. Or if you notice here, you're starting out with an A and you're ending with an A, starting with a B, ending with a B, starting with a C, ending with a C. So make sure those two match. And now what we do is just substitute the numbers that they gave us, and then we're going to use our calculator to solve this. So the next line down will be r squared is equal to p is 63 squared plus q is 107 squared minus 2 times 63 times 107 times the cosine of angle r, which is 42 degrees. And now we're going to just plug that into our calculator. We have to make sure, though, that the mode is set to degree mode, or else it's not going to work correctly. And we'll just put the whole thing in like this, 63 squared plus 107 squared. Just type it all on one line in your calculator. Minus 2 times 63 times 107. And then you don't have to put times if you don't want to. You can just press the cosine button, 42. And you'll end up with a long decimal, and that's what r squared is. So r squared is equal to 5398.921463. And then to find r, you take the square root of that number. So square root of second negative. You don't have to type it all over again. And your answer will be 73.47733534, and it says we want it to the nearest tenth, so this 7 would round this 4 up to a 5, so it's approximately equal to 73.5. And just go back and make sure that your number kind of makes sense with the other numbers. Like if we got this number and we stopped this 5,399 number, it really wouldn't make sense that these two sides are 107 and 63 and then this is over 5,000. So make sure that you just take a look and that this number is in line with the other numbers. So that's it. That's how you use the law of cosines. It's really not that difficult after you've practiced it a few times. So let's practice it again. Now we have a triangle called ABC, and they've labeled everything here, but they haven't labeled what the little letters are. So across from big B is little b, across from big A is little a, and across from big C is little c. And they want us to find the length of AC. Well, the length of AC is little b to the nearest tenth. So we've got a side, angle, side situation. If you noticed here, we've got side, angle, side information. And as we get along in later in this chapter, we're going to really have to know about what we're given. Sometimes we're not given side, angle, side, but in these situations we are. So when we have side, angle, side, angle, side, we say we're going to use the law of cosines. And we just, since we're asked to find little b, we start out with b squared in the law of cosines. So b squared is the other sides squared and added together. And then you subtract from that 2 times a times c times the cosine of this little b here ends with the big B over here. And then you just plug in the numbers that they're given us. Little a is 13, little c is 8, and big B is 110. So we're just going to plug that into our calculator. 13 squared plus 8 squared minus 2 times 13 times 8 times the cosine of 110 degrees. So b squared is equal to 304.14018898. And then you take the square root of that number and you get 17, and that's kind of in line with the other numbers. It should be longer than the other two because B is the longest side of this triangle. It should be a little bit longer than 13, and it looks like it is. So B is equal to 17.43961553, and rounding that to the nearest tenth, this 3 keeps the 4 of 4, so 17.4, and there's our answer for number example 2. Over on the other side, sometimes they get tricky in these examples and they give us some information, and we're going to have to figure out some other information before we apply the law of cosines. So here we have an isosceles triangle. So if you remember from geometry class, you draw an isosceles triangle with 2 equal sides like this. This is isosceles. And the legs are the 2 sides that are equal to each other. So the legs are 15 inches. So we're going to mark a 15 for both of those. And the base angles, remember from geometry class that base means the bottom, and these bottom angles each measure 36 degrees. So we've got 36 degrees for the 2 base angles. And we want to find the length of the base. So we want to find out how long this is. This is the base and these are the legs. So we don't have any letters, so we can just insert our own letters. I usually call it ABC, so we'll call this ABC, this triangle. And you can put any letters you want in any position, but just make sure that across from big A is little a, across from big C is little c, and across from big B is little b. So if they want us to find the base, we're going to find little b. So if we want to find B, we need side angle side information. We need big B. So we need to find this measure. We don't have it, but if we remember that all 3 angles in a triangle add up to 180, we can say angle B is equal to 180 minus the 2 sides added up, the other 2 sides added up. So we'll just do 180 minus 36 plus 36. And the other angle is 108 degrees. Well, I don't have this drawn very well because 108 is obtuse. Oh well, it doesn't really matter. So big B is 108 degrees. So now we have everything we need to use the law of cosines to find B, which says B squared is the other two sides squared and added together, minus 2 times A times C times the cosine of big B, which now we know. A squared is 15 squared, C squared is another 15 squared, minus 2 times 15 times 15 times the cosine of 108 degrees. Put that in our calculator, 15 squared plus 15 squared, 2 times 15 times 15 times the cosine of 108. And it looks like it's 589. 0.05764775, and then take the square root of that number, and B is equal to 24.270500983, and they want it to the nearest tenth of an inch, so this 7 would round this 2 up to 24.3. And that's kind of in line with the other two, 15. You know 108 is obtuse, so this should be the largest side of the triangle, and that kind of makes sense. In example 4, sometimes they'll give us a parallelogram problem, and this parallelogram problem has sides of length 10 and 14. So here are the two shorter sides. They're equal because it's a parallelogram. The longer sides are equal. So these are each 14. And it says one angle is equal to 110 degrees. Well, this is obtuse. So finding the obtuse angles in this parallelogram, these are 110 degrees, both of these. And if you remember with parallelograms, these two this angle and this angle add up to 180. So if we wanted to, we could insert a 70 degrees in here and a 70 degrees in here, but we might not need that information. Let's read on further. Find the length of the shorter diagonal to the nearest tenth. Well, a parallelogram has a longer diagonal that connects the acute angles, and it has a shorter diagonal which connects the two obtuse angles. So they want the length of this. Well, this whole angle is 110, not just this part. And so these two, we have to remember that base angles of a parallelogram add to 180 degrees. So if this angle is 110, this angle must be 70 degrees. And now what we have is we have a triangle where we have side, angle, side, and we can label this triangle whatever we want. We'll call it ABC because that's what we like the best usually. So we're just going to ignore this top triangle here, and we're going to use just this bottom. I think I'll outline it in red so it'll be easier to see. So we have this triangle down here. And so this side of opposite A is little a, and that's what we're asked to find is the shorter diagonal. This side across from big C is little c, and across from big B is little b. So if we want to find little a, the law of cosines says a squared is equal to the other two sides squared minus 2 times the other two sides times the cosine of the angle in between, which is big A. So a squared is equal to 14 squared plus 10 squared minus 2 times 14 times 10 times the cosine of 70 degrees. Put that in our calculator. And it's 200.234. 3599. So take the square root of that, and it's 14.15. 41907. And what do they want? To the nearest tenth again. So this 5 rounds the 1 up to a 2, so approximately 14.2, which makes sense. It's in line with the other two sides, the 14 and the 10. And the last thing I'm going to show you on this page is we can also use the law of cosines not only to find the side, but to find an angle measure, which is a little bit different. And this is a very weird looking thing, but let me show you how you get this formula. If you start out with a squared equals b squared plus c squared minus 2bc, 2bc cosine of a. If you want to find out how big this angle A is, you're going to subtract b squared and c squared from both sides of the equation. So this becomes a squared minus b squared minus c squared. Because those two go away, we're left with a negative 2bc cosine of a. We're just solving this for the cosine of a right now. So now what we're going to do is divide both sides by negative 2bc to cancel those out. And what we're left with is the cosine of a is equal to this. And to solve for this angle A, you're going to do second cos or inverse cos of a squared minus b squared minus c squared all over negative 2bc, and that is equal to angle A, because if you know the cosine, then you do the inverse cosine of this. So that's how this formula came about. But what we're going to do now is I'm going to show you how to solve for all three angles of this triangle. Now it says the sides of the triangle are 20, 22, and 25. Well, this looks like it's the shortest, this looks like it's the middle, and this looks like it's the largest, 25. And we don't know what this is called, so we'll just call it ABC like we usually do. So 22 is little a, 25 is little b, and 20 is little c. And now what they want is the largest angle. Well, the largest angle is angle B. So what we're going to do is, because we're trying to find big B, we can start out with b squared equals a squared plus c squared minus 2ac cosine of big B. Right, because we're trying to find big B here, we leave off with big B. So we're going to subtract a squared and c squared from both sides, b squared minus a squared minus c squared. And then we're going to divide both sides by negative 2ac, and that's equal to the cosine of b. So now what I'm going to do is put in the little b, the little a, and the little c into my calculator, and then do an inverse cosine of this. So what we have is b squared is 25 squared, a squared is 22 squared, and c squared is 20 squared, divided by negative 2 times a, which is 22, times c, which is 20, and that is equal to the cosine of b. So now what I'm going to do is take my fraction button on the calculator so I don't have to worry about parentheses. Please use your fraction button on these because people get messed up if they don't. So we've got 25 squared minus 22 squared minus 20 squared, all divided by negative 2 times 22 times 20. And there's the cosine of b, 259 over 880. And if I want to know what the angle is, you do second cos of that answer, and your calculator will tell you to the nearest degree, no, to the nearest tenth of a degree, 72.9 degrees. So the largest angle looks like it's 72.9 degrees. So there's one situation. Now we're going to find the smallest angle. Well, the smallest angle is across from the smallest side, so that would be angle C. So if we want to find angle C, we're going to start the law of cosines with c squared. So we've got c squared equals a squared plus b squared minus 2ab cosine of c. And you're going to subtract a squared and b squared from each side and divide both sides by the negative 2ab. And that is equal to the cosine of c. So now we're just going to plug the numbers in. C squared is 20 squared. A squared is 22 squared, and b squared is 25 squared, all over negative 2 times 22 times 25, and that is equal to the cosine of big C. So let's do our fraction button, and we'll put 20 squared minus 22 squared minus 25 squared, all over negative 2 times 22 times 25. And that's 709 over 1100. And we do second cosine of that angle, which is 49.9 degrees. And that's the smallest angle. And now you just have to add those two up and subtract from 180 to get the third angle. So 180 minus 72.9 minus 49.9 will be that. 180 minus 72.9 minus 49.9, and you got your third angle, 57.2 degrees. And the bell's rung, so I think that's about it for today. See you tomorrow.